Good day, I am Marga and for today I will be discussing tension members, bolted and riveted connections. So this is the second topic of principles of steel design, and I will be basing my discussion on NSCP 2001. So I will be simplifying the discussion made by our instructor so that it will be easier for our dear students to understand this lesson on tension members. So let's get started. So first is we need to understand the different modes of failure in our tension members. So for me, there are 5 modes of failure in tension members. So the first one is the cross-sectional yielding, the tensile rupture stress, or commonly known as the fracture or the tearing of our bolt and the plate. And we also have this black shear, the bearing stress within plates and rivets, and the shearing stress only happens in our bolts or rivets. Okay. Now first is we have to tackle the cross-sectional yielding. So cross-sectional yielding for the tensile force P is just equal to 0.60 F sub y, or our yield strength, times the cross-sectional area. So this is just the formula here, and we all have to know what AG is all about. So this A sub G is our cross-sectional area, and it refers from this region to this region here. So this one. As long as wala siya kaning mga bolt connections dire or rivets, okay, that will be considered as our cross-sectional area. We are just considering the width and the thickness lang naman. So naka-width diha times its thickness. So that will be your cross-sectional area. Okay, nasabta na siya, or yielding lang. Eh, di ba kay as kaning nga member is ato siyang ipul, di ba mo less than, di ba na iya ang like size at this point, for example diri kaya ito i-consider before failure. Second is the tensile rupture stress, the tearing or fracture. So the available or the safe tensile force is equal to the 0.50 F sub U times A sub N. F sub U here is our ultimate tensile for strength, and our A sub N here refers to the net area. So when we say net area, it's just this point here wherein ang atong fracture is moagi sa ato ang bolt connections, or pwede diri or pwede diri. Okay, so simple na siya, no? Okay, next is the block shear. So for our block shear, it's just 0.50 F sub U A sub T plus 0.30 F sub U A sub V. So dalian gyapon ni siya kay we all have to determine the A sub T here. We all know that A sub T is our area of detention on side. So if kani siya mo itong block shear path number 1, ang failure is for the area of detention, mo ni siya kani diri nga area warning for our tension. Tension side or tension niya. Tapos diri din na region is our shear. Shear na siya nga side. Okay, or the V. Or V. Kani is T. So for the block shear natin different path of failure. Pwede siya kani mapat ma-detach siya sa mga bolts, or pwede kani from this point here up to this point. So pwede siya, no? Tapos analyze lang din nato kung ano tong area ani diri, area din diri. So for this one, ma-times 2 na nga to ang shear area din sa shear, kay kana to consider first times 2 na dayon. Whereas diri isa lang, di ba? Isa for tension, isa sa area lang for your shear. Okay, ato i-analyze na niya. Next is the bearing stress between plates and rivets. So aside from this formula na 1.2 F sub U, A sub B, na di ba P is equal to 1.5 in accordance sa NSEP 2001 FUAB. Since we all know that for the safe tensile forces na allowed for our tension members, we are always reminded of the fact that we have to choose the smaller value. So therefore, kung ato na silang i-compare, same na sila FU and A sub B. But nag-differ lang silang coefficient, which is the 1.2 and the 1.5. So for me, dapat ato i-consider lang isang 1.2 F sub U, A sub B. It's because it will yield or it will result to a smaller value. Diba? So it's practical that we will be using this one only. Okay, now, bearing stress is a compressive stress that is caused by the reaction force of the rivets against the plate. So bearing stress is about the reaction force of the rivet against the plate. So basically, it's about the stress between the plate and the rivets, diba? Kung saan kuan. So as assumed equal ra ang force nga gina na ay gina act against sa ato ang rivets. For example, natay 5 kabot, lima na siya, example ay 6. So gi-assume na to nga kanitanan sila ng mga bolts or rivets is the same ra ang ilahang reaction force, diba, at a specific tensile force na divide lang kung pila ano siya. So for this one, basically nga to ang A sub here, it's just base times height. Atong base is ang ato ang diameter times the thickness nila ni. O kung pila na sila kabuok times n. Kung pila kabuok bolts or rivets. Simple ra. Okay, next. Okay, if bearing stress is too high, it can cause the material to deform and ultimately fail. Okay, that's why kailangan nato i-consider nga gamay ang value sa to ang bearing stress. So that's what ang designing is okay, ma-determine nato nga at that specific force or tensile force is mag-start na og fail ang ato ang tension member. Next is the shearing stress in bolts or rivets. So basically, this shearing stress will only happen sa to ang bolts and rivets. So pwede nga to ang bolts and rivets is mag-fracture siya and it will feel like this as drawn naka-shear man siya, shear stress. Okay, when a tension member is subjected to a tensile force, the bolts that connect the member to other components, such as plates or gussets, can experience a shearing force that is perpendicular to the tensile force. Okay, if this is your force nga gi-apply nga to ang shearing stress will be perpendicular, pwede siya nga paana, kaya pwede po siya nga ang ani gapon as or yes, perpendicular perpendicular. If the shearing force exceeds the strength of the bolt, it can cause the bolt to shear off, leading to failure of the tension member. So kung mag-fail na siya kaya ang ani, ma-detach na siya matangtang. Right now. So ang imong tensile force is just equal to the allowable shearing stress times A sub B ganing capital. So what do you mean by this A sub B? So this A sub B only refers to the area of this shear kaning shear area sa toong bolt or rivet. So for here rivet man siya no, rivet. So area sa toong rivet lang gina-consider na it's just the area sa circle, di ba? Okay, circular man na pi over 4d squared times number of rivets or number of bolts. Ana ra? Wala ni siya. Tapos kaning F sub B or ang ato ang allowable shear stress given na siya sa mga problem. Actually na siya. Now, these are the steps in analyzing the safe value of the tensile force P. Kini sa itong mga problems, always man na gina-ask nga what is the safe value that the connection can resist, but also we all have to know the basic steps in analyzing what the value of our tensile force P is. And basically, dapat mag-yield siya sa lowest nga value. Dili pwede nga dako yung value, no? Tapos man itong answer, no. Because a specific value, kani sa lowest value, diya man mag-fail ang atuang tension member. So what if katong dako imong gipili? So mag-fail na daan ang atuang member sa kani siya nga mode of failure. Like wala pa siya nakaabot anak nga strength, nag-fail na siya. So it means we need to get the lowest value. So these are the steps. So natay first, we have to determine the diameter of the hole D sub H using the following cases. So this is very important because this diameter of the hole serves to like allowance biton naman siya kung mag-calculate naka for the value of RP in different modes of failure. So for me, based on experience, natay tulo ka cases na i-consider in terms sa NSCP 2001 because this problem actually kay muna siya ang mga problems na until now sa board exam daw according to Jelisania is gagawas din siya. So case 1 ta. If it is indicated that the rivets used are hot driven, so na word na hot driven, no? Or indicate nga A502 grades 1 or A502 grades 2. Directly use this one. D sub H equal to dB plus 1.6 is dB is our diameter of the bolt or diameter of the rivets nga use. I-specify man na pilang diameter. Tapos, kung gingon nga hot driven, 1.6 na natin. So, gets. So I think sa muang maestro which is sa engineering marking goni, kanila yung gi-atag sa muang nga case which is for me medyo simple la siya kay igo na ba magkano 1.6, diba? Case 2, if it is not indicated that the rivets used are hot driven or A502 grades 1 and 2, wala siya gi-indicate, wala ning hot driven, wala siya gi-indicate ha. Perform the two-step procedures. So, saan yung two-step procedures? So, first is we need to get the standard diameter. Ano ito makita ng standard diameter? Dari nga table. Table 510-6. This is in accordance to our NSCP 2001. Okay na, standard diameter kani. For example, sa problem giingon nga naka-bolt diameter nga 20 mm. Bolt diameter 20 mm. And wala siya specify na hot driven. Therefore, ay case 2 ka. 20 mm pangitaw mo 20 plus 21. So meaning atong standard nga diameter is now 21 mm. Na next, second step is apply na din kani. Ayan ka mag-apply sa dB plus 1.6. So apply din ka diri. DH equal to dB plus 1.6. So nakay DH nga kani is your 21 plus 1.6, 22.6 mm. So muna itong gamiton. And this value sa D sub H is very important siya sa ato ang tensile rupture stress and also for block shear. Okay. Muna siyang ginagamit yun always. Okay. Sabta ng case 2. Okay na sa case 2. Basta duha ka procedure. Next, case 3. So, ito na case 3. If it is indicated how much the diameter of the hole as compared to the stated diameter of the rivet, then we can use it directly. So, meaning, kung giingan sa problem kani siya is 1 millimeters larger than the rivet diameter, di ka na nga condition atong i-follow. So for example, the rivet holes are 3.2 millimeters larger than the rivet diameter, which is 25 millimeters. Therefore, kani nga statement atong i-follow. Okay, kay giingon naman siya sa problem nga kani nga condition. So therefore, di nato magamit sa case 1 o case 2. Nara sa case 3. Therefore, d sub h nato is just 25 plus 3.2 is equal to 28.2 millimeters. So this will be our diameter of the hole, or d sub h. Nasabtan ba? Okay. Now, second step. Okay, katong first ken ato tong usa-usa at kung different cases. Now, applying the different modes of failure. First is we have the gross-sectional yielding. So for our gross-sectional yielding, P is equal to 0.6 F sub y Ag raman, right? I consider na mga gross sectional area is katong part nga walay bolt connection. Okay, di ba? Thickness times plate width raman, di ba? Gross sectional area. So, okay na kani. Letter B, tensile rupture stress. Your tearing or fractures along your bolt connection or rivet connection. So, we need to consider D sub H. Same sa toong block shear. Consider na to ng diameter sa H. Kani o. Kani sila. Gamito na din na to siya mga value. That's why need na to sila pangitaon jud first. Kay magamit to siya sa 4 tensile rupture stress or block shear. Now, we need to know that for our tensile rupture stress, i-compare na to dyan na always itong A sub N o 0.85 A sub G. Your net area must be less than or equal to 0.85 of your gross-sectional area. Now, what if mas dako ning 0.85 A sub G? Mas dako ni siya. Meaning mas dako what if mas dako imuhang A sub N as compared to your 0.85 A sub G? So, meaning, yung gamiton is kani, 0.85 A sub G. Dili ka mo gamit ani. For instance, so, ana siya, there is a need or it is very important na ito sila compare. So that, kung kinsay mas gamay sa ilaha, mo itong gamiton. Okay? Ana siya. Especially, kung ang imuha, kung musunod na ka sa ginatawag nato na unstaggered bolt connection in succeeding rows. So, kana siya, pasok na dito. Kaya need na to sila i-compare. Next is we have the block shear. So, for block shear, same raman to, no? Kunin mo ang area sa tension, kunin mo ang area sa imuhang shear side. So, kato sila, kato formula, ang 0.5 FU 80 plus 0.3 FU AV. So, mo raman to, no? Gamitin niyo pa niyo ang D sub H. Next is you have the bearing stress between plates and rivets. So for this one, we have to consider the original bolt or rivet diameter. So diri, for example, the rivet holes at 3.2 millimeters larger than the rivet diameter 25 millimeters. So dili ka mo gamit ani for bearing stress between plates sa area. Ibang area ni kay A sa B man to. Dili naman ni gamiton ang 28.2. Imong gamiton is kaning 25. Di bang original jud? Imong gamiton original. Ang original jud ang gamiton dili ang kabit. Joke lang. So next is for shearing stress in bolts and rivets. So same sa bearing stress, gamiton na to always ang original, not the DH. Okay? So that's di ba? Ang A sa B man to nga capital, di ba? Pi over 4 pi over 4d squared times n. N is the number of bolt connection. And lastly is we have to select the lowest p-value. So the lowest p-value always govern. It will be the safe value to be selected. So muna naman ang answer. Diba? Dali siya. Diba? Next is we have the actually loaded connections. So what do you mean by this? If there is 2 or more unstaggered rows, for example, na kay gasket plate diri, example, nakay gusset plate, nakay ani. So ipasabot ani niya. Okay, ato siya masana. If tearing occurs along succeeding rows less than 100% of P acts on the net area since part of that force will have already been transferred to other plate. So ipasabot ra niya is that, for example, na kay isa diri 1, isang connection. Succeeding man na kay 2 dapat diri 2, diri 3, ana. Kung napay space diya 4, 5, 6. So meaning staggered siya, ay kwan siya no, ga-increase ang number sa imong bolts in succession. Okay, in succeeding rows. So per row kaniya row ni siya ha, because dapat ang orientation ani is di ba pa upward unta, pero since for analysis man ato siyang gi-rotate, gi-landscape na to siya. Sakto ba? Yeah, gi-landscape na to siya. So row siya. So di ba nag-increase ang iyang number of bolts kada row in a what? In a specific pattern. Okay. So matawag na to ni siya nga unstaggered. It's because ang iyang mode of failure ana is straight line pagyapon always ana straight line. Straight line very straight line. So sa analysis nimo ana isa-isahon dyan mo siya or in straight line imuhang pag-analyze, dili siya ang paana because if na naipaing ani ano na siya staggered na siya, staggered connections, then we'll be using the Cochrane's formula, which is the S squared over 4G. But for now, based sa discussion, wala man nigi-introduce. So yeah, stick lang dito sa what was the discussion all about. Okay, hence atong a sub n prime is equal to your a sub n over 1 minus n over n nga capital, wherein your a sub n is the actual net area which must be less than or equal to 0.85 your gross-sectional area. Next, n nga gamay or small letter n is the total number of bolts in front of the section being considered. So, for instance, kanino bolt connection, dinin na ka mo consider gani. So, pila ang imuhang pila ang number of pila mong n nga small kani, pila imong n nga gamay. Di ba nga total number of bolts in front of the section being considered. So, meaning na kay 1 over n nga dako. N is a total number of bolts. So, diri total number of bolts 1, 2, 3, 4, 5, 6. Na kay 6 or 1, 6. Ana. For, kung di ka mag-analyze nga region, kinasabtan. For your a sub n prime, muna imong new values imong net area if your a sub n meets the condition nga a sub n is less than or equal to 0.85 a sub g, or else if dili siya ma-meet is that dili ka mo gamit ani. Okay, nasabtan ba? Dapat ma-meet ni siya condition, but if not, don't use this. Do not use this. Do not use this. So meaning, kung dili siya masatisfy, kani mo gamiton ng 0.85 f sub g. Kani ra gyapon mo gamiton. Nasabtan. Okay, pang take note ka na na. If tearing occurs along succeeding rows, only the procedure in solving the net area will be different. So, di ba, tensile rupture stress, kay diri man ka mag-analyze kani. Diri na po dayon. Or kani ba diri. Di ba, dali lang. So, our next 3 videos will be a problem solving regarding these tension members. So, I hope na nasabtan na ninyo tanan akong gipang discuss, and see you sa problem solving. Bye.